quick demo of how InferX works in action. So let's see. So here there's our 60 models, anywhere from 1 billion parameters to 70B. We also have 70B here, as you can see. So in general, in order to serve all these models without any cold start penalty, this would take anywhere near 90 GPUs, more than 90 GPUs. But in our case, actually, we deployed all these 60 models in 2 A6000s, literally. Yeah, that's how efficient it is. And how we serve these models is basically when you upload your model, so we take a snapshot of the GPU and the CPU state of the model. So that includes the raw weights, the code context, the memory, and the state. So, and then we capture that and then we store them in the system memory. As you can see here, these are all the containerized parts here. So we store them right there. And these are all the snapshots here, so as you can see. And we store them in the system memory, and we bring it back into the VRAM, GPU VRAM, when it's called, when the API is called, on demand in a couple of seconds. And then the model immediately gets loaded, and once it is done inferencing, and then the model gets evicted, and we make the GPU available for the next model. Let me show you how it works in action. So let's pick a 7B model here, right? And let's give it a go. What happens? So right here, so 7B model is about 1.3 second, and what happened in the background is, so let me show you here. So that model is actually taking the 2 GPUs. You can see it's GPU 0 and a GPU 1. And let's go back to the models again, and we pick a different model. So let's do a 12B model here, and let's give it a go. And there it is. It's about a 1.3 second. And let's go back again and see what's happening in the background. The old model gets evicted, and then it's taking the new model again. See, it's taking a GPU 0 and it's GPU 1. And just like that, actually, you can also let me show you how the GPU is also shared. So let's call it small model here. It's a 1.5 billion parameter model, so it's pretty quick because it's a very small model. It's about 0.5 second. And let's go back again. See, I mean, you can see the previous model, the 12B model, is taking GPU 0 and 1, and this one, the small model we call, they're also taking GPU 0. So basically, they're sharing the GPU. So the GPU can also be split into multiple parts basically. So that's how. So you can go back to the model, and you can pick a GPU. This is actually 70B. It's the biggest model actually. Let's see. So yeah, that's about 2.5 seconds, right? So this is actually A6000. So if you deployed it on a H100 or H200, this is even much more faster actually. We were able to get it under almost 1.5 second. And the B200, forget about it. I mean, that would be way more faster. And as we can see the 70B model is actually taking GPU 0 and GPU 1. So just like that, you can serve all these models on demand. You can just call all these models, you know. So boom, and this just goes up, and then you can go back and call another model just like that. Boom, 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 and this. See, it's all happening. The entire orchestration is happening in a very secure container runtime, as you can see here. So basically, all these models can be just served in using a couple of A6000. That's how efficient inference can become, literally. So we don't need to waste the GPU by keeping the model live 24/7 and just waiting for the models, just because you don't want to avoid the cold start penalty. So and InferX can be deployed on the cloud as well as on-prem as well. And so it's a complete platform. You won't need anything, and it can be deployed on top of Kubernetes as well. Got it. Thank you.